Okay, so I realized that I had to download this Read Anywhere app, and whenever you go to that, if you end up downloading it to your device or whatever, it should list your book on there, so you can be able to figure out where you are here. Okay. I thought that it was already downloaded, but I guess it's not. All right, so once you go to it, it's going to ask you to download that chapter. And then you can go to the different sections that way. So I think we were like around laws and principles. And I just kind of wanted to show you how to access your textbook. It's possible that you're able to just view it on the computer, but for whatever reason on my iPad, it's making me do this image reader thing. So, all right, let me go back to my PowerPoint here. So, laws and principles. A law is an important relationship that's observed to occur time after time. So, like Charles's law between temperature and pressure in gases, kind of like if you heat it, like up a balloon or something, it's going to cause the pressure in that balloon to change, and therefore that balloon is going to float. And then we have like the difference between laws and principles. So a principle is a little bit more descriptive. They're using like Archimedes' principle, which is relating objects and fluids and buoyancy. So it's all I really want you to know about a principle is that it's more specific than a law. A law is kind of like, another example that I give is that every time you put a glass of water in a freezer, what happens? Well, it freezes. Well, why? Well, the why actually gets into the theory part, but the law is that it happens every time. The theory is that there are these like water molecules inside of it. So you've got H2O, and before they're just like liquid water, but when you put them into the freezer, then these bonds start to get really rigid and become a solid, and then it freezes into ice. Well, can we actually see that happening? Well, no. That's why it's a theory. A theory is based on some evidence, experiments, but can't really prove it. A model is a collection of theories or ideas, and you can use all kinds of ways to do a model, a physical or mathematical model. I tend to think of like a solar system or atomic model. And then they're showing you an example being like a rainbow. Okay, so I want to go over the rules to significant figures really quick. And I would like for you guys to write these down with me. Okay, so the first rule is that for all whole numbers, zeros after non-zero numbers are not significant. So an example being like 1,000. So that would be one significant figure because these zeros are not significant. However, if you add a decimal, the zeros are significant. So 1,000 with a decimal would be 4 significant figures. And then the second rule, decimal numbers, zeros before the non-zero number are not significant. So like 0.005. Those zeros right there are not significant. So this is one significant figure. Those zeros are just placeholders. However, zeros after the non-zero number are significant. So an example would be like that. It would be 2 significant figures. Okay, and then there's like a third rule that sandwiched, I know that's kind of a funny word, zeros are significant. So an example being 500,500. So 500,500. How many significant figures is that? We'll see how these 2 zeros are between 2 non-zero numbers. So those are significant. These, however, are not significant. Why not? Because that is like this example. There's no decimal. So this number is 4 significant figures. If there was a decimal, then it would be 6. But since there's not, it's only 4. Okay, I hope this helps. If you have any questions, let me know.